As we learned on the last lesson, functions, the graph of functions have parent functions, which is like the original graph. But these parent functions can suffer some transformations, depending on the math operation that we use to these parent functions, that we apply to this parent function. For example, on a screen, we can see f of x equals x squared. The parent function of x squared is a parabola, or this U shape looking upwards. But what happens if we add a constant? Let's say we add a positive a, where a could be any number. All that happens is this is a vertical transformation because the addition or the subtraction is happening outside of the square, outside of the function. So all this means is a vertical transformation upwards by the amount of units that a is. So we're going to move this parabola a units up. We have positive a, so we move up. In this same logic, if instead of having positive a, we have a negative a, then the graph moves downwards. Because if the operation is happening outside of the x squared, then it's a vertical shift and we moved in the same direction that the constant is telling us. Negative a, we move in the negative y direction. But vertical transformations are not the only transformations, because we also have horizontal transformations, and this happens when the operation is inside of the square, like in this situation. The a is inside of the parentheses, so we're moving the graph horizontally. Now, something to be very careful is when moving or having horizontal transformations, we go in the opposite direction. If we have positive a inside of the parentheses, we need to move in the negative a direction or in the negative x direction. So positive constant, remember a represents any number, we moved to the left. Then, of course, if negative means to the left, then if positive means to the left, then negative means to the right. In this situation, we have negative a inside of the parentheses, which means we have to move to the right in the positive x direction. So negative a inside of the parentheses, we moved to the right. Of course, we have some other transformations, so let's bring the graph back to the original x squared. And let's try now multiplying times a constant. When we multiply the x squared or the parent function times a constant, the graph is going to stretch. It's going to get stretched. It's more vertical. It's thinner. That stretch of the graph is the same amount of that a. So we moved by that magnitude. And of course, if we have multiplication, it means we also have division. When we divide, the graph compresses. So it's flatter and is going to compress by that same amount that we are dividing. We have one more transformation that our graphs can experience. So let's go back to our x squared. And this last transformation is when we multiply times a negative. And we put a negative in front of the function. This negative represents a reflection about the x-axis. Or in other words, our graph rotates 180 degrees. So it was pointing upwards, it is now pointing downwards. And these are all of our transformations. And these transformations happen for any function that we have. Let's try one more function. Let's try now the absolute value of x. The absolute value of x is quite similar to the x squared function, but instead of being a curve, it's a straight line. And for the absolute value, the transformations will be the same. If we have a positive a outside of the absolute value, it means we're going to move this absolute value function a units in the positive vertical direction. Every time we have additions or subtractions outside of the function, it's a vertical shift, and we always move in the same direction. If we have a negative a, then we move downwards. Positive a upwards, negative a downwards. So we keep it consistent. For the vertical movements or for the vertical transformations, if we have a positive, we move positive. If we have negative, we move negative. Similar situations, we also have horizontal transformations. Horizontal transformations happen when the addition or the subtraction is inside of the function, like in this situation, the a is inside of the absolute value. But if we have a positive a, we need to move in the negative a direction. So positive a, negative a direction. That means every time we do horizontal transformations, we have to go in the opposite. If it says positive, we move to the left. And of course, if it says negative, like in this situation, we move to the right. Always for horizontal transformations, we moved in the opposite direction. Let's go back to our absolute value, because absolute values also have multiplications by constant, like in this case, a times the absolute value of x. And let's remember one more time, this a represents any number, 2, 3, 4, 10, 100, 1000. And if we multiply, our graph stretches by the amount we are multiplying. And also, if we have division, then our graph compresses by the amount that we are dividing. So the transformations are the same. The thing that changes is the parent function. So depending on whether we have addition, subtraction, multiplication, or division, outside or inside, our parent function is going to have a transformation, but that transformation just depends on the parent function. So the transformation will be the same, but the shape of the parent function will be different. And finally, we have the case in which we multiply our absolute value by a negative, and all this means this negative in front of the absolute value is reflection over the x-axis. And these are all the graph transformations that we're going to analyze in this lesson. In part 2 of this lesson, we're going to do the same transformations, but for a different parent function.